Hi students, welcome back to ChemPath. I'm really glad you are here. In the last video, we have started with the chapter solution where we have defined what is solution, then we have seen what are solutes and solvents, then we have discussed about types of solution. There are three types of solutions: gaseous solution, then liquid solution and solid solution, and we have also seen examples for them, and then we have defined some terminologies such as binary solutions, tertiary solution, aqueous solution, then non-aqueous solution, saturated solution and unsaturated solution. And also we have discussed some factors deciding solubility. There are three factors which decides solubility: nature of solute and solvent, temperature and pressure. So these are the things that we have discussed in the last video. So in today's video, let us start with methods of expressing concentration of solution. Methods of expressing concentration of solution. Okay. Now what do you mean by concentration of solution? What do you mean by concentration of solution? So it is the amount of solute present in the given quantity of solute or solvent. ಅಂತ ಹೇಳಿದ್ರೆ ಈಗೊಂದು ಎಕ್ಸಾಂಪಲ್, ಈಗೊಂದು ನಾವು ಶುಗರ್ ಸೊಲ್ಯೂಷನ್ ತೊಗೊಂಡ್ರೆ ಆ ಸೊಲ್ಯೂಷನಲ್ಲಿ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಸೊಲ್ಯೂಟ್ ಯಾವುದಲ್ಲಿ? ಶುಗರ್. ಸೊ ಶುಗರ್ ಯಾವುದರಲ್ಲಿ ತನ್ನನ್ನು ಡಿಸಾಲ್ವ್ ಮಾಡಿಕೊಳ್ತದೋ ಅದು ಸೊಲ್ಯೂಟ್ ಅಂತ ಹೇಳುವಂಥದ್ದು. ಸೊ ಶುಗರ್ ಸೊಲ್ಯೂಷನಲ್ಲಿ ಶುಗರ್ ಸೊಲ್ಯೂಟ್ ಆಗಿರ್ತದೆ. ಸೊ ಆ ಶುಗರ್ ಎಷ್ಟು ಅಮೌಂಟಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಇದೆ ಅಂತ ಹೇಳೋದನ್ನು ನಾವು ಆ ಸೊಲ್ಯೂಷನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂತ ಹೇಳ್ತೇವೆ. Now this concentration of solution can be expressed by following methods. So guys, there are several methods to express concentration of solution. So they are mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity and normality. So next let us discuss one by one. So first one, mass percentage. So how can you define this? How will you going to define this mass percentage? So it is the amount of solute in grams dissolved per 100 gram of solution. So the total amount of solute in grams and which is dissolved per 100 gram of solution. So the formula to this mass percentage is given like this. Mass percentage of solute is equal to mass of the solute in solution by total mass of solution into 100. Okay, by using this formula we are going to calculate mass percentage. And next one is volume percentage. So how we are going to define this? So it is the volume of solute dissolved per 100 ml of solution. So here guys, note, we have taken the term volume. So volume is measured in ml, liter, etc. You know this, right? So how we are going to define? It is the ratio of volume of solute dissolved per 100 ml of solution. So the formula is written like this. Volume percentage of a solute is equal to volume of solute by total volume of the solution into 100. Now the third method of expressing concentration is mass by volume percentage, and this is defined as it is the ratio of mass of solute dissolved per 100 ml of solution. Okay, so it is the ratio of mass of solute dissolved per 100 ml of solution. So here we are taking the percentage for 100 ml of solution. For 100 ml of solution, how much of mass solute is dissolved, that is calculated here. Okay, mass by volume percentage of solute is equal to mass of solute by volume of solution into 100. So this is the formula used here. And fourth one is parts per million. So guys, when we are going to calculate or when we are using this, so when a solute is present in trace quantities, it is convenient to express concentration in parts per million. ಅಂತ ಹೇಳಿದ್ರೆ ಈಗ ಸೊಲ್ಯೂಟ್ ತುಂಬ ಸ್ಮಾಲ್ ಅಮೌಂಟಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಇದ್ದಾಗ ನಾವು ಈ ಪಾರ್ಟ್ಸ್ ಪರ್ ಮಿಲಿಯನನ್ನು ಯೂಸ್ ಮಾಡ್ತೇವೆ. Okay, the formula to calculate parts per million is number of parts of the component by total number of parts of all components of the solution into 10 to the power 6. So next fifth one is mole fraction, and symbol used to denote this mole fraction is chi. Okay, this is a symbol. This is read as chi. Now this is defined as, or the definition for mole fraction is, it is the ratio of moles of a particular component to the total number of moles of all the components. So here guys, we are calculating mole fraction of particular component. So that means if we consider a solution, there are more than two or more than two components, right? So by using this mole fraction, we are going to find out mole fraction of single component. And this mole fraction is, or formula for mole fraction is written like this: mole fraction of a component is equal to number of moles of the component by total number of moles of all the components. So this is the formula which we use. So for example, if we consider a binary solution, so guys, you know binary solution means they are the solutions having two components, right? Binary. So now for this binary solution, we are going to find out mole fraction of each component. Okay, so that is if we consider one component or one solute as A and solvent as B, or we can say one component is named as A and another component is named as B, then mole fraction of component A is written like this: chi A is equal to Na. So here this is written in subscript, guys. Na by Na plus Nb, that is number of moles of component A by number of moles of component A plus number of moles of component B. By using this formula, we are going to calculate each component's mole fraction. So here chi A, this mole fraction of component A, and Na means number of moles of component A, and Nb means number of moles of component B. Similarly, mole fraction of component B. So here now we need to find out mole fraction of next component. That is chi B is equal to Nb by Na plus Nb, where chi B is mole fraction of component B. Nb means number of moles of component B by Na means number of moles of component A plus number of moles of component B. Okay, so take this note, guys. For a binary solution, mole fraction of solute plus mole fraction of solvent, which will be always 1. Okay. Next, methods of expressing concentration is molarity, and which is denoted by capital M. So molarity is denoted by capital M. Now this is defined as, it is the number of moles of solute per liter of solution. In 1 liter of solution, how many number of moles of solute are dissolved? That is calculated using molarity. And formula to calculate molarity is equal to moles of solute by volume of solution in liter. Okay, so that is written as molarity, which is noted as capital M is equal to moles of solute, that is Nb, volume of solution as V. So this is given here, where M is molarity, Nb means number of moles of solute, V is volume of solution. Or this formula can also be written like this: M is equal to Wb into 1000 by Mb into V, and unit of this molarity is mole per liter. Okay, now here M means molarity, Wb means weight of the solute, Mb means molar mass of solute, and V means volume of solution. So this is about molarity. Next one is molality, which is denoted by small letter m. Molality, small letter m. Now this is defined as, it is the ratio of number of moles of solute per 1 kg of solvent. Number of moles of solute present in 1 kg of solvent. So the formula for this molality is equal to moles of solute by mass of solvent in kg. Okay, this is written like this: molality, which is denoted by small m, is equal to mass of solute, that is N, by mass of solvent, that is W, weight. Okay, mass. Or this formula can also be written like this: M is equal to WB into 1000 by MB into WA. And unit for this molality is mole per kg. Okay, now take this note, students. So here one question arises, and which is important for your exam also. Temperature does not affect molality and mole fraction. Why? So guys, this mole fraction, molarity, then mass percent, all these concentrations does not affect by temperature. And they're asking why temperature does not affect these concentrations. So answer is, this is because they are based on mass and moles which do not change with temperature. That means these molality and mole fraction, they are independent of temperature, and only molarity depends on temperature, or temperature affects only molarity, not molality and mole fraction. And molality is based on mass and mole fraction is based on moles, right? Therefore they do not change with temperature. Next, last type is normality, which is denoted by capital letter N. Now it is defined as, it is the number of gram equivalents of solute dissolved in 1 liter of solution. So how you are going to define normality? It is the number of gram equivalents of solute dissolved in 1 liter of solution. And the formula given to calculate normality is N is equal to number of gram equivalents of solute by volume of solution in liter. So by using this formula, we are going to calculate normality. So next, let us see some of the problems. So first problem is, calculate the mass percentage of benzene. The formula of benzene is C6H6 and carbon tetrachloride CCl4. If 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. So this is the problem, guys. So here what we have to do, we need to calculate mass percentage of benzene and carbon tetrachloride. And what are given here? Mass of benzene is given, that is 22 gram, and carbon tetrachloride is 122 gram. So while solving this, first we need to write given. What is given in the question? Okay. Mass of benzene 22 gram, mass of carbon tetrachloride 122 gram is given in this question. So these are the data given in this question. Now first let us write the formula that we have seen while discussing mass percentage. Mass percentage of solute is equal to mass of solute in the solution by total mass of the solution into 100. So this is the formula that we have seen when we discussed mass percentage of solute, right? Now I will take this as equation 1, and now I will convert this equation into according to the question. Okay, so that is equation 1 implies, so here solute, which is solute here? Benzene is solute, right? So mass percent of benzene is equal to mass of benzene solution by total mass of solution into 100. So I will consider this as equation number 2. So here in the formula, we don't know total mass of solution. We know mass of benzene, right? That is 22 gram. And also we know mass of carbon tetrachloride. But we don't know total mass of solution. So first we need to find total mass of solution. That is calculated like this. Mass of benzene plus mass of carbon tetrachloride. 22 gram plus 122 gram. That is equal to 144 gram. Now we got total mass of solution. Now let's substitute this total mass of solution in equation number 2. So equation number 2, which implies mass percent of benzene equal to 22 gram by 144 gram into 100. When this is solved, here gram cancels, and when it is solved, this becomes 15.27%. Okay, in the same manner, let us find out mass percent of carbon tetrachloride. The formula is mass of carbon tetrachloride in solution by total mass of the solution into 100. So mass of carbon tetrachloride we know, that is given in the question, 122 gram, and we have calculated total mass of the solution, that is 144 gram into 100. and this becomes 84.72%. Okay, I hope this problem you have understood, and please take down these two questions as homework. And 10 gram, second question is, that is 10 gram of glucose is dissolved in 90 gram of water. Now what is the mass percentage of glucose in resulting solution? This is solved same like this. In this way you have to solve this. And next one is 10 ml of ethanol is dissolved in 90 ml of water. What is the volume percentage of ethanol in solution? So here in this problem you have to take volume percentage formula. Okay, guys, try to solve this. If you find difficult, please put a comment. I'll solve in the next video. Next problem that I have taken on mole fraction. Let us see the question first. Calculate the mole fraction of urea where molar mass is 60 gram per mole in aqueous solution containing 40% of urea by mass. So this is the question, guys. First let us write down what is given in this question. Okay, mass of urea is given, that is urea, its percentage is given. Mass of urea's percentage is given, that is 40%. 40% means it is known, that is taken in 100, right? Therefore it is 40%. So in 100, 40% means it is 40 gram. Then mass of water 60 gram. Okay, 60 gram. And molar mass of urea is given 60 gram per mole. Then, so guys, here how I have taken water as 60 gram? Because they said 40% of urea, 40% of urea in 100, right? In 100 this is taken. So in 100, so this is a solution which is made up of urea and water, right? So in 100, 40% is urea means remaining 60 is water, right? So I have taken here 60 grams mass of water. Then molar mass of water is 18 gram per mole. And let us put the formula here. Therefore, number of moles of urea, N urea is equal to mass or weight of urea by molar or molecular mass of urea. That is weight of urea. Weight of urea is 40 gram and molecular mass is 60 gram per mole. So when we solve this gram cancels, and when we solve, we get 0.66 mole. Okay. Next, let us discuss mass of moles of water. That is N water is equal to mass or weight of water by molar or molecular mass of water. Next, weight of water is 60 gram by molar mass is 18 gram per mole. And when we solve this, we get 3.33 mole. And next, let us find mole fraction of urea, which is found like this. Chi of urea is equal to N urea by N urea plus N water. This formula is used to calculate. Let us substitute the values here. So N urea is 0.66 mole by N urea 0.66 mole plus N water 3.33 mole, which we have calculated earlier. Okay. So the answer comes 0.165. So next, mole fraction of water. That is chi water is equal to N water by N urea plus N water. So this is the formula. So we need to find out chi water, that is mole fraction of water. So N water we have found 3.33 mole by 0.66 mole plus 3.33 mole. And when we solve this, we get 0.834. Okay. There is no unit for mole fraction. So now let us add chi mole fraction of urea and mole fraction of water, that is chi urea and chi water. So when we add this one and this one, we obtain 0.999 as answer. So these are the two problems that we have solved. So guys, if you want more problems, please drop a comment in a comment section and I will solve them in next video. And if you like this video, please like, share and subscribe my channel. And thank you.